Okay, another way that we can solve statically indeterminate problems is by using the method of superposition. So basically, superposition comes up a lot in strength of materials kind of applications and just in engineering in general. And basically what the idea is the loads can be solved in individual little pieces and then added together to get the final answer. And this is basically what's called superpositioning the loads on top of each other. So if I look at this here, once again, this is the same bar that I had before. Statically indeterminate problems happen when a system's over-constrained. It means that you have more forces than you need. And so how we go about solving the method of superposition is we choose a load, we declare it redundant, we solve the problem without the redundant load. And then what you do is you solve the problem for the redundant load and equate the two solutions. So what do I mean when I'm saying that? So if I got this thing here, and the first thing I'm going to do is I'm going to go, okay, you know what? That load B, that's redundant, so we're not going to use that. So what happens then is we take a look at it, and it's like, well, if I take B away, well, this is easy, because I can calculate how far it's going to deflect, because now I just have that internal force at A being caused by P, and I can calculate out, okay, it's going to deflect this, this much. So I have an internal force acting over that area, so I do my PL over AE equation, and that's going to tell us how much we're going to deflect at the end. Easy enough. But now what we have to do is, wait a second, well, I know that there's a wall there. So then what we end up doing is we go, okay, well, I'm going to ignore, put my ink in a bad spot there. It's not allowing me to grab my ink, but we'll just ignore it for now. So I'm going to ignore that there was any forces applied on it. I'm just going to go, okay, I have this deflection to B. So I'm just going to take this rod now, ignore everything else, and go just this force at B, I'm going to push up on there, and basically what I'm getting to is I have to get to figure out how much deflection I'm going to have at B. So how do I do that? Well, the deflection is going to be PL over AE, just like we did before. Now, where we're going to equate this is I'm going to say, okay, well, I have that deflection of P, which is from this one here, that I'm pushing it out beyond the wall. And then from here, I've got this deflection at B, where I'm basically pushing the bar back in. And then I say, okay, well, those two have to equal each other. And then I can solve the problem with my redundant load. And so superposition is a nice clean way of doing things. It's a different way of thinking about how we're going to do it. We're going to get to the same place that we got to using our kinematic equations. We're just going to look at it a little bit differently. And so this is the same thing, like with the kinematic equations. If there's a little gap there, well, we can account for the gap because, okay, that force is going to push back everything except that little gap. So that's the theory behind how this one works. It's a little bit easier to see in practice, I think, than in theory. So the next example, we will go over using this method for solving a problem.